And so the life cycle of the corn earworm, the eggs are laid inside of the silks of the corn, and they hatch and they feed on the corn. And as they feed, they grow to about 1.5 inches long, and they develop into pupas. And from there, they keep developing, and they turn into moths.
The natural enemies for the corn earworm are cannibalism. They eat each other when there's not enough food or it's just competition for them. And birds, bats, toads, and other predatory insects like a ladybug. And organic controls for our canola oil, a few drops of it, so it'll make it slippery for them to come off, or it prevents them from damaging the corn, and botanical pesticides. And management is sampling, insecticides, cultural practices, biological control, and host resistance. So the GMO corn, it usually has Bt gene added to the corn gene, which the cornworm digests, and it only kills the worm and not any other insect. The problem is the corn earworm is starting to get immune to it, and it's no longer organic.
So for our project, we want to create a robot, and basically it would inspect every ear of corn in the field, and it would have a built-in ultrasound, and it would ultrasound every ear of corn, and it would be able to spot treat the infected corn. And so it would detect the worms in GMO plants. And the reason why it would have to detect worms in GMO plants is because the corn earworm has to eat the corn in order to die. The Bt inside of the corn is what kills the worm. So in order for the worm to die, it has to mature enough to eat it. So it could only detect the worms in the GMO plants. And also, if you have organic plants, because a lot of the times people like organic foods now, so we want to detect the eggs inside the organic plants so that they don't have time to mature and already eat the food. So you can treat them beforehand, and your food can still be organic, and you kill the corn earworm. And the benefits to our project, our project is to save money, so you don't have to use insecticides on your whole entire field. And also, now the worms that are becoming more immune to the Bt, they can still be killed without using insecticides along your whole field. Any questions?
So if the psychological is a moth, do you think about how you can control the moth getting onto the corn so that we can do anything?
Well, we have, hold up, back here. Oh, they have sampling, so it's like traps for insects and pests, and we did sampling and capturing pests. So sometimes, and it's kind of hard to capture a whole entire group of large moths, but the moths aren't what's killing the plants. So yeah.
It's them laying their eggs.
Yes.
You said a benefit would be saving the cost on the pesticides, but how much do you think this robotic deployment system would be?
Okay. Well, we looked up that. How much was it?
It was $99, but usually if you're buying insecticides, it costs you have to buy it every 3 months, and it'll be around $30. So if you go ahead and buy the ultrasound, it'll be easier.
Yeah, because the ultrasound is not really that expensive. I mean, for commercial use, it might be a little more expensive, but yeah, basic ultrasound is only $99. So yeah, it would save money because you don't have to use insecticides on your whole entire field, which is becomes expensive every season for planting. Yeah.
So are farmers having to use even more insecticide now with the resistance to these modified plants?
Yes. Yeah.
Would people have to change the way they plant the corn, like the distance between rows and the distance between plants in order for the robot to move through the field?
Well, hopefully we can make a small enough robot, because now the the move is for like smaller technology, so it'd be able to do more things in compact spaces. So, you know, smaller is better, so that's what we're shooting for.
Put it on a drone maybe?
Yeah. Oh yeah, I could fly across